One of the things that we learned in our past discussions is the Bronsted-Lowry acid-base mechanism. Here, we learned that water molecule can act both as an acid or as a base. For example, when hydrofluoric acid is dissolved in water, water will act here as a base. As an acid, hydrofluoric acid will donate hydrogen to the water, and water molecule will now turn into hydronium ion or H3O positive. Our base here is water, and our conjugate acid is hydronium ion. On the other hand, after its donation to water, hydrofluoric acid will now turn into fluoride ion. Our acid is hydrofluoric acid, and its conjugate base is fluoride ion. But what if, for example, we created a solution made of the parent acid or base and a salt of its conjugate? For example, let's take hydrofluoric acid. What if we created a solution made of hydrofluoric acid and sodium fluoride? We know that sodium fluoride is a salt with fluoride ion, and we know that fluoride is actually a conjugate base of hydrofluoric acid. What will be this resulting solution? Most especially, what will be the special characteristic of this solution? This solution that we have here, hydrofluoric acid and sodium fluoride, is an example of this type of solution known as a buffer. Buffer solution is a solution of weak acid and the salt of its conjugate base, or a weak base and the salt of its conjugate acid. In our prior example, we have here the combination of hydrofluoric acid and sodium fluoride. Here, we know that our weak acid is hydrofluoric acid and its conjugate is fluoride ion. So, in order to create a buffer solution with hydrofluoric acid, we need to combine this hydrofluoric acid to a salt with fluoride ion. And what I chose here was sodium fluoride. Therefore, combination of hydrofluoric acid and sodium fluoride can create a buffer solution. Now, one of the most important characteristics of buffer solution is that it can resist a sudden change in pH. That is why buffer solution is a very important component in food products, in cosmetics, and even in our body. In fact, in our blood, we can find a buffer solution known as the bicarbonate buffer. Okay? This is actually an equation that shows a bicarbonate buffer. We know that carbonic acid is a weak acid, and once we dissolve this one into water, it will create positively charged hydrogen and negatively charged bicarbonate ion. Our weak acid here is carbonic acid. Our conjugate base here is bicarbonate ion. Therefore, by combining carbonic acid and a salt of its conjugate, which is bicarbonate, any salt that has actually bicarbonate, let's say sodium bicarbonate, potassium bicarbonate, and so on and so forth, the resulting solution will be a buffer solution. Earlier, we said that buffer solutions are important components in food and cosmetic products. But how is it possible that buffer solutions do not greatly change or alter the acidity or basicity of the products where they are combined? To understand how buffer solution works, let's have here the common ion effect. Common ion effect is the shift in position in equilibrium away from the side with common ion added. To understand this concept, let's have here hydrofluoric acid again as our example. When hydrofluoric acid is dissolved in water, it will turn into positively charged hydronium ion and negatively charged fluoride ion. Now take note, the higher the hydronium ion, the more acidic the solution will be. And therefore, if we combine this hydrofluoric acid to a food or cosmetic product, eventually this hydrofluoric acid will dissociate into hydronium ion, and therefore it will turn the food or cosmetic product acidic. Now, to prevent that from happening, what we need to do is to stop the dissociation to happen, to prevent the dissociation to happen. We need to prevent this hydrofluoric acid to dissociate into hydronium ion so that the pH of the food or cosmetic products where they are combined or where this one is combined will not greatly change or will not greatly be affected. Okay, so in this case, to do that, what I am going to do is to find a common ion that can be found here in this side of the equation and find a salt with that common ion. In this case, what I am going to do is to find a salt with fluoride ion. What I chose here was sodium fluoride. Sodium fluoride has actually a fluoride ion. And when we dissolve sodium fluoride in water, it will release fluoride ion, positively charged sodium and negatively charged fluoride ion. Now, if we, for example, in this equation, we added sodium fluoride, of course, there will now be a source of fluorine ion or fluoride ion here, and it will now increase the stress here in this side of the equation. Remember that one of the causes of stress in a chemical reaction is the increase in concentration. So, in this case, we are going to increase the concentration of fluoride ion in this side of the equation using a salt with fluoride, that is sodium fluoride. So, if we are going to, if we increase the concentration of fluoride ion here, okay, this equilibrium will now be broken and it will now shift the reaction to the left side of the equation. Okay, therefore, okay, there will be more hydrofluoric acid and water, and there will be less hydronium ion. Therefore, our buffer solution here is hydrofluoric acid and sodium fluoride. Now again, one of the most important characteristics of buffer solution is that it can resist a sudden change in pH. But how does a buffer solution do that? So let's give here an example. Okay. Let's say we have here a buffer solution made of carbonic acid and a salt of its conjugate. Let's say we have here sodium bicarbonate. Okay, by the way, the conjugate of this carbonic acid is bicarbonate, so any salt with bicarbonate will do. Okay, in this case, our acid here is carbonic acid and our base here is the salt of its conjugate, which is the bicarbonate. Now, if a base, let's say if hydroxide ion is added to this buffer solution, the carbonic acid will be the one that will react against the added hydroxide ion or base. So as an acid, carbonic acid will donate hydrogen to the hydroxide ion that has been added or to the base that has been added. And after the addition of hydrogen or donation of hydrogen, this hydroxide ion will now turn into H2O or HOH or water, which is actually a neutral compound. And again, after the donation of hydrogen, this carbonic acid here will now turn into bicarbonate ion, which is actually already existing in our buffer solution. Therefore, apparently, nothing happened or nothing is added to the system. Parang wala lang nangyari kasi na-convert naman yung ating dinagdag na base into water and bicarbonate ion, which was already existing in the solution. Now, what about if, for example, we added hydronium ion or we added acid? We added an acid to the system, to this buffer solution. Then, the one that will react against that added acid or hydronium ion is not this one, not this carbonic acid, but this one, the base. Okay, so what will happen here is that the additional acid or the additional hydronium ion will now act as an acid, and as an acid, it will now donate hydrogen to bicarbonate ion, to our bicarbonate ion. Now, after the addition or after the donation of hydrogen, okay, our hydronium ion will now turn into water molecule, which is again neutral, and our bicarbonate ion here will now turn into carbonic acid, which was again already existing in our buffer solution. Therefore, apparently, nothing happened because our hydronium ion here is actually converted using this one, using our bicarbonate here. Our hydronium ion is actually converted into water and carbonic acid, which was already existing in the solution. So that is how the buffer solution works. Okay, so thank you for listening and good day.